What is series combination of cell? When a number of cells are connected one after another in this way across any resistance, then such combination of cells are known as series combination of cell. Suppose each cell of EMF E internal resistance R. Each cell is of EMF E and internal resistance R, and it is connected to external resistance capital R. Let there are n cells in series. If we consider each cell as a resistance of value small r, then the total resistance for these cells will be n into r, because a number of resistances connected in series. So what is the equivalent internal resistance? This R equivalent is the equivalent internal resistance, that is R plus R plus R, so on up to n terms. So the result is NR. So equivalent internal resistance equal to NR. And what is R external? External resistance is capital R. If the current I, which is flowing through the circuit due to this combination of cells, then I is equal to, we have the formula current I equal to E divided by R plus R. E is the EMF of the cell, R is the external resistance connected to the circuit, and small r is the internal resistance. What will be the equivalent EMF between these 2 points? If a number of cells each of EMF E connected, then E equivalent, that is equivalent EMF of the cell, can be written as NE. When n cells each of EMF E connected in parallel, then equivalent EMF is NE, equivalent internal resistance is NR. So this can be written as NE divided by capital R plus N into small r. This is the equation of current which is flowing through the external resistance R when n cells each of EMF is E and internal resistance small r are connected in series. Now in this case we are going to discuss 2 different situations. First situation is, suppose capital R is very much larger than small r. If the external resistance connected in the circuit is very much larger than internal resistance, in that case R plus NR is nearly equal to capital R. Means you are going to neglect this NR. So what is the current which is flowing through the circuit? I will be equal to NE divided by R. So N into E by R. Means n times this E by R is the current drawn from one cell. So n times the current drawn from one cell we are getting in case capital R is very much larger than small r. Second case, if small r is very much larger than capital R, in that case R plus NR is nearly equal to NR. Because in this case small r, capital R is very much smaller, so we are going to neglect it. So what is I? It is NE divided by NR, which is E by R. So that is the current drawn from one cell. So from this discussion it is clear that it is advantageous to connect n numbers of cells in series when the external resistance connected in the circuit is very much larger in comparison to the internal resistance of each cell. In case the internal resistance of each cell is very much larger than the external resistance connected to the circuit, we get the series combination of cell has got a disadvantage. Means you connect a number of cells, but you are getting the current which is drawn from one cell, which is a type of disadvantage. So we can say that we should connect the cells in series only when the external resistance connected to the circuit is very much larger than internal resistance. In case of parallel combination, how we connect the resistors? We connect all the left end of all the resistors together, right end of all the resistors together. Same method we follow here. The positive terminal of all the cells are connected together. Let in this way n cells are connected in parallel. Okay, each cell of EMF E internal resistance R, EMF E internal resistance R, EMF E internal resistance R. And these cells are connected across the external resistance capital R. Now, what will be the equivalent EMF in this case and what will be the equivalent internal resistance in this case? Here, E equivalent will be equal to EMF of one cell. You can connect in this way 100 cells, each of EMF 1.5 volt. You will be getting equivalent EMF 1.5 volt because they are connected to same two terminals A and B. So potential difference between these two terminals through any cell remains same. Now, if you consider each cell as a resistance small r, then you can say n resistors are connected in series. How many cells we have taken? We have taken n cells. So what is the equivalent internal resistance? 1 by R equivalent equal to 1 by R plus 1 by R plus 1 by R, so on up to n terms. So 1 by R equivalent equal to, we are getting n into 1 by R, that is n by R. So what is R equivalent? R equivalent equal to R by N. So equivalent EMF is E, equivalent internal resistance is R by N. So what is the current which is flowing through the circuit in this case? I equal to E divided by capital R plus small r is the formula. Here E is E only, capital R is capital R only, and this is R by N. So it is NE divided by NR plus small r. This is the equation of current in parallel combination of cells. Now again we discuss two cases. First case, if the external resistance is very much larger than internal resistance. If external resistance is very much larger than internal resistance, then NR plus small r is nearly equal to NR. And I is equal to NE by NR, which is equal to E by R. So what is that? It is a disadvantage or advantage? It is disadvantage because you have connected n number of cells, but you are getting the current drawn from one cell. But when capital R was greater than small r, this case was the case of advantage in series combination. Now the second case, if small r very much larger than capital R, if small r is very much larger than capital R, in that case NR plus small r is nearly equal to small r. So what is current I? It is NE divided by R, that is N times E by R. N times E by small r. So in this case, what we can say, if the external resistance connected in the circuit is very much larger than internal resistance, then it is disadvantageous to connect the cells in parallel. If internal resistance of the cell is very much larger than external resistance, then we prefer to connect the cells in parallel.